All right, good morning. Can you hear me okay? All right, perfect. All right, so I get next 20 minutes to talk about the technology and the enablers for artificial intelligence. So first of all, what do I do? I've been 20 plus years in the IT industry. I have been very intimately involved with the government agencies for last 15 years. I really spend my time with the technology. As you see, the title says Chief Technology Officer. So I love the innovative technology that's out there from NVIDIA, Dell, Splunk, Nutanix. I get to play with all those things. Me and my engineering team spend time in the lab trying to bring this to life, right? So I'm a true believer in like taking the technology and being able to solve real problems, right, with the mission problem. So I spend a lot of time with the customers. So in the next 20 minutes, I just want to give you a scoop of what's the art of the possible, what's out there, and basically what technology components would you need to bring this to life. So can we have the next slide? Next one. All right. So here's the agenda. I'll talk quickly about the current state. We heard about the previous speakers, where we are, what's the possible. One of the things I want to talk about is how do you pick those AI workloads? What are the characteristics of those? What are some of the simple use cases that you can start with in your agency with AI and ML? What is the maturity model look like? Where are we today and where it's going? And then I want to spend some time on this, what I've developed as a 7-layer technology stack. You might have all heard about the OSI 7-layer stack. So this is the AI 7-layer stack. And I'll make sure you get a copy of this slide. So there's a lot of good content. And finally, what is the roadmap to success and how can GAI help you? Next slide. So I'm not going to spend time on this, right? You know, you heard in the previous speech from the previous speakers, AI and ML is a tsunami. It's a massive disruptive technology that's coming, and we are just at the start of it. So over the years, we have seen the PC, the internet, the social media, and recently the cloud in the last 10 years have caused a massive disruption, right? So with the IoT, robotics, quantum computing, and artificial intelligence, machine learning, when I see the art of the possible, it just blows my mind. It's like sky's the limit what you can do with it. Next one. So I just want to set the stage with 3 things. Today with artificial intelligence, we are at a stage called artificial narrow intelligence. These are the official terms that are coined by the research companies, right? ANI is the artificial narrow intelligence. Today's machines, today's artificial intelligence can do one thing really well. They do not have broad capabilities like humans, right? For example, your Siri and Alexas and all the Cortana and all the things that you deal with today, the smart devices, they do one thing and they do really well, and they are getting better. They don't do really well, but they're getting better, and they are designed for one thing, right? Even sensors that go into the autonomous vehicles, driving cars. But if you had the same device and you try to make it do something else, it would not be able to do it, right? But that's the next level, which is artificial general intelligence, which is where the market will be in next 20 years, where the same device, same technology should be able to do multiple things and adapt just the way humans do. So for example, if you ask Siri today, hey, what's the weather? It can tell you what's the weather and it can answer simple questions. But ask Siri to write an English essay for you. It's not going to do it. But when it's artificial general intelligence, it can do much more intelligent things. And finally, the scary part is after another 20 years or so, we will hopefully be at the ASI, which is artificial superintelligence, where the machines become collectively smarter than humans, which we don't know what the outcome will be, but that's too far out, another 40, 50 years, at least based on what the research is saying. Next slide. So what are some of the workloads that we can immediately start with? What are some of the easy things? So I have put 4 things here. So if you look on the left side, there is all of you in your agency, in your organizations are dealing with a lot of back office operations. Mundane, repetitive tasks that are non-subjective, which people are spending hours and thousands of hours throughout the year. Can we take some of those tasks which are not challenging, they're mundane, they're ordinary, right? Can we take those and automate those? The answer is absolutely yes. Not only we can do it, it's being done. And that process is called RPA, Robotic Process Automation. Next one is a large diverse data sets in a data lake. Many of the government customers I talk to, they are creating data lakes. They're dumping a lot of data, structured data, unstructured data, GIS data, spatial data, drone data, streaming data, but they're like, one day I'll get to it and I'll analyze it, but there's a time value of data. You can't just have the data sit there. You need some analytics right now. That's where AI can come in handy. The third one is the cyber. I live and breathe cyber. I've been doing that for 15 years. And we have come a long way with cybersecurity, but you all will agree with me that we are nowhere close to saying that we have conquered the challenge of cyber. Every single week, you look at some article and you see that there was some major breach with some agency or some organization around the world, and you have seen ransomware and advanced persistent threats, and it just never ends. So clearly, the technology we have today is not really powerful enough, but AI has the potential and it's already happening. And fourth is the large-scale IoT data coming from sensors, right? The cameras, the videos, all the drones, and that's another part of the. So these are the 4 use cases. The one on the left, the ordinary mundane task, is the one that's already being done, and the rest are being developed as we speak. Next one. So here are some other use cases that affect the mission. So this is what I do. I sit down with my customers, and one size will never fit all, right? Every customer, every agency has a different mission. There is so many different things you can do with AI and ML, right? As you see some of the use cases here, again, we don't have the time to go through all this, but this is the type of things I do in my workshop that I conduct, is pick on 1 or 2 of these use cases and we go deep, right? You may have challenges around insider threat detection. Can AI solve that? Absolutely. You are collecting GIS data or satellite data and you want to be able to do fusion with unstructured data and make out some sense out of it. You may want to be looking at preventive maintenance or predictive analytics around, let's say, Air Force. They are doing F-35 fighter jets, looking at all the different data coming from the engine temperature, sensors, airframe stressors, and so many different thousands of sensors, and those data that is coming from the sensors are being fed into the deep learning algorithm, and they are able to see when the certain part is likely to break before it breaks. So that's already happening. There's a whole ton of use cases here, and this is a work in progress, right? There could be chat bots, there could be software bots, there could be facial recognition. Again, every day, every week, I read more about it and see the art of the possible. It just it amazes me, and the technology is here today. Next slide. So let me talk 2 minutes on the robotic process automation. So this is the one use case that I have seen many agencies have already started doing, where, as I mentioned, if you have back office operations, right? Like if you want to fill out some application, you want to do purchase orders, you want to do accounts payable, claims processing, loan processing, any of these tasks, just look around and see how many people you have employed today and where you still don't have resources, and it's an administrative burden. It takes hours and hours, and there is a big backlog, right? These are the things that today can be automated right away. The software is already there. It's called robotic process automation. There are attended bots and unattended bots, or it could be hybrid bots. So tasks like these can be easily automated with simple bots on your desktops that can be sitting with you and helping you, or they could be told to do what to do, and they can do that in the background while you're working on something else. So there is one government agency who started doing this, and they have saved 15,000 hours per year and almost 8 full-time employees. Now you may say, but what do I do with those people that are freed up? Where are we hurting the most? Cybersecurity. We don't have enough analysts in the SOC. We don't have enough budget to be able to hire more people. Why don't we free up these people from mundane tasks, be able to train them and put them where the mission needs are? So that's a very good use case. I feel that's the low-hanging fruit that all of us can look at and start with. Next slide. So how is the technology maturing? Today, if you see at the bottom, you have descriptive analytics and diagnostic analytics. Tell me what happened yesterday. Tell me what happened in 5 years ago. Tell me what happened day before yesterday. I mean, it's all about what already happened. But if you see where this is going is predictive analytics, what we call as prescriptive analytics, and third is cognitive analytics. It's not about what happened. Yes, I like to know about what happened and why it happened, but I would rather like to know what's likely to happen. And why would it happen and what can I do about it? And it could be anything. It could be healthcare. It could be predictive maintenance of fighter jets. It could be vehicles. It could be anything. Use case is up to you how you want to apply that. But this is where the technology is going. And cognitive. Cognitive means I do not have time to sit and learn all this myself. I want natural language processing. I want machines to be smart. I should be able to ask questions in plain English, and it should be able to give me the answers. If you guys heard about Dr. Watson from IBM, they have been trying to do that for a long time. But all those things that we thought was just fun are coming together. And with NVIDIA and Dell and all these companies we work with, I mean, this is today here. It's already here, and it's getting better. Next. So how does the process work in artificial intelligence and machine learning? It's simple 3-step process. You feed the data, and it's all kinds of data. If you don't have good data, you're not going to get good output. It's plain and simple. The good data sets, rich data sets, and those data sets have to be properly cleaned and classified and tagged. You feed that into the middle layer, which is the learning system. There could be supervised learning, unsupervised learning. And there is all kinds of open source libraries out there, which I'll talk about in a minute. And third, once that learning happens, now you get the output, which is, we call it as rich visualization, right? Where the data scientist will spend most of their time analyzing and making decisions. So it's a 3-step process. Next slide. So this is one of the important slides I want to talk about, the 7 layers of the AI stack. What do I need from a technology perspective as an agency for me to be ready to be able to take advantage of this big disruptive revolution of technology? So I divided it into 7 steps. Let's start from the bottom. Layer 1 is your infrastructure. I cannot emphasize enough how important it is to have a right infrastructure. I mean, because this is going to be massive stress on the compute, memory, storage, all the traditional technologies that you have been using. Usually the old legacy technologies will not be able to scale. As you are modernizing your infrastructure, this is the thing to think today. What can I do to be ready to take the advantage of AI and ML so that you don't have to rip and replace again after 2 or 3 years? So what's out there is, so you may have heard about things like hybrid cloud. Many of you are already doing hybrid cloud. That is a perfect technology because the power of cloud is massive. You can do lots of computation, both on-premise as well as in the public cloud. Hyper-converged infrastructure, I'm a big fan of that. I've been on that technology for 5 years. I have helped a lot of government agencies get onto hyper-converged, whether it's Nutanix or Dell EMC, VxRail, vSAN, VMware. There is multiple options. But hyper-converged is absolutely a key technology because it collapses the 3 tiers into single tier, reduces the latency, and allows you to scale from an artificial intelligence perspective. You also need to have an excellent storage, optimized storage, object storage, flash storage. It doesn't matter what version of storage you use, but look at what storage you have today and can it keep up with the massive amount of demands of the infrastructure, of the AI data sets. You also need to look at purpose-built appliances. I don't know how many of you have heard of DGX boxes, DGX1, DGX2 from NVIDIA. If you have not heard about it, you may want to look it up. DGX2 is the new one that got released in March at the GTC, and it's a box. It's literally a small mini refrigerator size box. It's purpose-built appliance. It's from NVIDIA. It has a power of 300 servers, equivalent to 15 racks in that small machine. It's not a machine, it's a supercomputer. And it is packed with 2 petaflops of power, compute power, with 16 Tesla V100 GPUs, right? We just heard about the power of GPUs. GPUs is what you will need. CPUs are not going to take you there if you are trying to do anything with artificial intelligence and machine learning. For example, a CPU technology will take you, let's say something 2 months. you can get that done with GPU technology in literally 2 days. So it's a massive time compression. So container technology, containerization, we heard about that from the previous speakers, right? Containers allow you to take microservices, applications, and port it from one location to another location without being stuck on a specific hardware. You can move it between clouds, you can move it between private infrastructure. There's a technology called Kubernetes. And now Kubernetes is one, it came from Google, and it is fully supported by NVIDIA through their GPU cores, and it allows you to orchestrate those containers from any location, any infrastructure to any infrastructure. You need that portability as you are developing these applications. So data lakes, virtualization, object storage, next generation security platforms, I mean, all this, you cannot take it lightly. This is the foundation. Then you go to the next level, which is smart endpoints, Internet of Things, drones, sensors, smart devices, autonomous systems, right? That is where the data is actually coming from. Layer 3 is the data ingestion and preparation, where what you are able to do now is take that data, clean it, classify it, and be able to normalize it, tag it, label it. And if I don't do all that, you know, when I'm analyzing that data in a deep learning system, I'm going to get wrong output. So this phase is very important, and there are multiple tools out there that can help you with that. Next one is actually the software layer, the next two layers. Layer 4 and layer 5 are what we call as deep learning user frameworks, user software and frameworks. How many of you have heard of things like TensorFlow, PyTorch, Caffe, right? Theano, Apache Singak, Scikit, Panda, H2O. If all this sounds Latin and Greek to you, don't be worried, because it's all the new technologies that are out there. These are the open source libraries. Many of them are based on Python. Like for example, TensorFlow and PyTorch are my two favorite. I have used those and I have read about those. They are absolutely mature, and they allow you to take a lot of your deep learning algorithms and be able to train that machine or that data for being able to get the output that you're looking for. But you will need those frameworks. You don't need all of them. You need to pick one. Deep learning user software. How many of you heard about the NVIDIA announced Rapids just last month? Rapids is basically the open source software libraries for data science, all packaged together for the data scientists, so they can put their entire data science pipeline on the GPU optimized appliances. So NVIDIA Digits, NVIDIA Rapids, there are a lot of choices out there, and there are some open source, there are some that are already packaged for you. Then we go on to the containerized AI applications. There are a whole bunch of startups that are part of the ecosystem of the AI and ML that are creating innovative solutions like Graph Database, MapD, Omniscience, BlazingDB, right? I can go on and on. There are so many unique niche applications, whether it's robotic process automation like companies like UiPath, Blue Prism, Automation Anywhere, right? All these special applications are the ones that sit on the top. And finally, the last layer, layer 7, is the visualization layer. This is where you will need to be ready to bring in the data scientists. I also recommend having a artificial intelligence center of excellence. A lot of government agencies I've talked to, they have started doing that. You will need a dedicated team. You will need a focus. You will need some buy-in from the leadership from the top as you are developing these solutions. So this is the 7-layer stack. To make it easy, I just put a little mnemonic there. Important enablers designed for ultimate AI visualization. If you look at the first word, it's I is the infrastructure, enablers is the endpoints, D is designed is the data ingestion, for is the frameworks, U ultimate is the user, AI is the AI applications, and visualization is your visualization. So just easy to remember what are the 7 things I need in a complete stack. It's very, very straightforward. If you have these 7 things, you are on to a very good start. I mean, and again, you don't need to be having all of them ready today, but you have to start planning. That's my message here. Next slide. So as a government agency, what's the roadmap to success? I have 5 things here. Identify the problem, get the endorsement, assess the capabilities, look for partnership, and create the right mindset, right? You need to have right approach. starting with finding the use case, all the way to having the right partnership with companies like GI, NVIDIA, whoever you pick. There has to be your advisor, your mentor as you are developing this. You will need help. And finally, having the right mindset within the agency. Next slide. And I'm a big believer in pilots and proof of concepts. We have done that for many agencies and it works really well. You can, if you are not sure about the technology, you don't know where to start, you have to think about a pilot or a use case, right? And how do you do that? And so you have to make sure you have the efficient workflow, the right resources, motivated leaders, the clear blessings from the leadership, clean data, and then finally success criteria, what you define as a true proof of concept success. Next slide. And this, I'm not going to go into details, but at GAI we develop solutions. One of our solution is called HyperCap, Hyperconverged Analytics Platform. We are continuing to deploy this in several agencies. It's a full stack, and we have continued to evolve it to include AI and ML use cases. So I will be here after the event, or I'll have my information. Feel free to come engage me and my team, and we can come and tell you how this can help you, the full stack. Next slide. And last slide. So how is GAI, how can GAI enable you? There are 4 things we can help you with. Number 1 is educational workshops. I am a true believer in starting with education, and because many of us do not know what's the art of the possible. So we have 2 types of workshops, one for the business decision makers, one for the technical decision makers. We call it market research workshops. And 2 hours, 4 hours, depends on which one you want to go for, but it will actually give you a good, it will open your mind, it will show you what's possible and where should I start. Number 2, we are very good at solution enablement. I truly live in the labs with my engineers, and we take all this amazing technology and we kick the tires, we put it together. So before I come and stand in front of you, we have done some research and we have already put solutions together. Number 3 is the professional services, project management. It's a full effort, right, from pre-sales to post-sales to technology lifecycle management, getting ongoing support. That's the 3rd area we help. And 4th is our contracts, right, from ITES to SOUP to so your procurement vehicles. So that's the GAI story. Then I would say look at number 1, which is your educational workshops, and I love to come and do those market research workshops, engage with my team, and you will love it, I promise you. Next slide. And that's my email. Thank you. I went about a little bit, about 5 minutes, but hopefully you found something useful. And I am here, my team is here, if you guys like to come and see me. Okay, thank you so much.